Okay, so let's take a moment and talk about something that's going to come up from time to time, and that's the trivial sum. The sum of the empty set. So the trivial sum, the best way, or one way to kind of think about deriving what it means and an understanding of the trivial sum is to look at the progression of these vectors or these sums. So here we have the sum of 3 vectors, and then you have the sum of 2 vectors, and we see that the difference between these two sums is vector 3. And then if we look at going from 2 vectors to 1 vector, we see that the difference between these two is vector 2. And then if we keep going like fashion, and we want to compare this to the next one, which would be the trivial sum, the empty set, then what's the difference between going from this to the empty set? And that's basically, we're subtracting off V1, right? So if we have the empty set, so we can define the sum of many vectors as the 0 vector, because what are we doing? Like I said, in passing to the trivial sum, the sum of many vectors, we can expect to subtract V1, and so that's where we define the sum of many vectors to be the 0 vector, because if we subtract off V1, we get the 0 vector. Okay? Now, the relation with the prior example is that if the 0 vector is in a set, then the set has an element that is a combination of a subset of other vectors from the set. Specifically, the 0 vector is a combination of the empty set. Okay? So, if you have a set that contains the 0 vector, then it is linearly dependent, because the 0 vector is the sum of the empty set, and the empty set is a subset of S right here. So if we define this as S, we have a linearly dependent set for those reasons. We've got the 0 vector, which is a combination of the empty set, and it's a subset of S. Okay, so just keep this in mind as we go on. Have a good day.